it's very easy to start. Okay, and trust me, it is little difficult to be in touch or to complete the journey. So I wish all of you that you complete this journey and get maximum out of it. Okay, it's very easy to start, but make an effort, keep your motivation high to finish this journey that you have started with Spartificial with this course. So once again, a very good evening to all of you. You can unmute and wish me as well.
Good evening, ma'am.
Good evening.
Good
Okay.
evening.
Good evening, ma'am.
Yeah, this was just to wake you up if you are looking forward in your screen, because we are in a virtual mode. So I am Jayati. I'm a scientist at ISRO, and I've come here for taking this orientation session with Spartificial on exploring this Mars. A few of my friends are there who are actually doing their PhD on Mars. So, but here the topic that Spartificial people have chosen is little different. It's like mixing Mars data with the machine learning. So let us start. Mars is there, and obviously it is waiting for us to be reached. But the thing is, we don't have to reach there at this point of time. We have to reach the data, analyze the data that we have got from Mars. Did you get my point?
Yes, ma'am.
Okay, if anytime any one of you is having any doubt or want to know anything, you can just unmute, stop me and let me know, okay? So before we start anything, okay, for example, you are doing this course, someone is doing an MBA, someone is doing some MTech, okay? You need to know three things. Yeah, that why are you doing that? What are you doing and how are you going to do it? Isn't it? For example, if you're doing an MBA, the reason could be getting a better job opportunities and maybe doing something in your field. What are you doing? You are going to study the forensic science, or here we can say the other one who was doing an MTech environment science. And how is you will be gaining different skills, and this course is maybe one of them. Yes.
Yes, ma'am.
Yes, yes.
Yeah. Okay, so let us look at this course, these 3 points for this course. So why are we studying Mars is the first thing that we will be discussing in detail in the first portion of this orientation session. Then what are we going to study? That is, a little bit detail about maths, about this Mars planet. For example, if you're doing a course, you will have a detail that this is the course curriculum that is there. This is approximately what I will be doing. Yes. Similarly, in this course, what we will be studying about Mars. So what is Mars? What are the information that we prerequisitely know? We will be just taking a quick view of it. And then we will go on to the most important part, that how you will be taking this course, or exactly what you will be studying in this course, how you will be linking this Mars ka data with the machine learning. But the most important thing is how it can help you. Yes. How many of you are interested to know that how it can help you?
I'm interested, ma'am.
Okay.
I am also.
Okay. So let me just take a minute. Yeah. So now I can see you. Okay. So I'll just brief you with the example that I have. I have talked with 3 people in this course. Okay. So it depends on what application you want to use the course which you will be dealing now. For example, to the one who is doing in this course, what you will be learning is, one is image data. On the image data, you will be implementing some machine learning algorithm. So this is the skill that you will be taking back from this course. Okay. And now you have to look forward that how you can use this skill set in your projects, whatever will be coming in your life. Did you get my point?
Yes,
Yes,
ma'am.
ma'am.
Yeah, for example, if you're doing an environment engineering, maybe you could be doing from the satellite image, doing the land use land cover classification to take out the vegetation cover. Yes. In that
Yes,
case,
ma'am. Yes, ma'am.
everything that will be same, the machine learning will be same. What will change is the data. Okay. And what is one big advantage when you are taking Mars is another dimension you are opening to yourself. Yes. About this astronomical study.
Yes, ma'am.
Hannah. So that is another thing that will keep you excited, because usually what happens if you do a simple course on machine learning, data science, deep learning, sorry, or whatever after a point of time, because there is nothing exciting. Okay? For example, if I give you an image of a city and I want you to classify that, classify building, classify tree, you are already well versed with it. You can see and let us know. Yes?
Yes, ma'am.
Anna. But in case of Mars, you don't know. Yes? Anyone here who's already a pro at Mars? I hope,
Yes.
Hannah, you are already.
Ma'am.
So to let that interest be on, this course is gonna help you. Okay. So now let us quickly go through that what we have the things to study in Mars, or a little bit about Mars, because I told you, the three things we will be focusing on: why, what, and how. Okay. Any project you do maybe in your future, say any small project or big project, or you just have to figure out three things: why, what, how. If these three things are figured out properly, result and discussion will be made automatically. Yeah. Okay. So just starting with it, so Mars is red planet and it is the fourth planet in our solar system. All of us are very aware of it, and we have been like very fascinated about it. Can you tell me the reason why do we have more fascination towards Mars, not about Jupiter, Venus, anything? Why Mars? हम मार्स को ही
According
क्यों
to
पढ़ना चाहते हैं?
according to studies, we have to come to know that Mars was having the same environment like Earth,
हाँ.
living environment, but eventually it was destroyed due to external factors of the solar system.
Mm-hmm.
So they came to know that, and they want to do experiments to further know what will be the impact on the Earth in coming future days, and how can we utilize the Mars environment, or whatever the left on the Mars, to continue our life further, life forms existence if anything happened on the Earth.
Okay, great. This is one good reason. Anyone else having a different answer? Okay, so I will tell you two reasons. One is the psychological reason, and another one is the practical reason. Before we enter into any scientific reason, yeah, there are two more things that is important. One is psychological, and another one is practical. You agree or not? Practically, if something is possible, we will be more attracted towards it. Yes?
Yes.
Hannah. So the psychological reason could be red attracts. Yes?
Yes, sir.
Okay, just kidding. The psychological reason is what she has already mentioned, that Mars is near to us, and we have always been fascinated because the atmosphere of Mars seems to be similar to us. And the practical reason being, between Earth and Mars, the asteroids are very less. If you see, there is an asteroid belt between Mars and Jupiter. Yes? So going beyond Jupiter is not that easy, but going until Mars is practically possible. Another reason is, when we go towards Sun, exploring the planets which are near to the Sun is difficult than exploring the planets which are little far from the Sun, from the Earth. Because what is big, Sun or Earth?
Sir.
Sun. And the Sun is very big than Earth. So because of the attraction, the sending a payload towards the Sun is much more difficult than sending it away, because Sun will have its own gravity. Sun will the rays would be coming from in that direction. So we have to kind of send in an opposite direction to the solar winds coming. Yes?
Yes.
So here in case of Mars, practically it was possible to reach. Okay. And why we could reach? Because we had a psychological thing that, these are the factors that play an important role to, and so we should study Mars. Okay. So the focus of any Mars mission is to scientifically study Mars and explore it. Now, what to explore in Mars? If we see Earth, I'm just comparing Earth with Mars, so that I can tell you that any planet we look forward for, what are the things we look forward for? The first thing is atmosphere. Yes.
Yes, ma'am.
Second, you can also speak up. I want you to speak up. Okay,
Surface of the terrain.
terrain. Okay. See, the reason why I ask you to speak up is you would have heard this saying that, energy flows in the direction of your attention. Yes, or you get results in the direction of your energy. Yes, no?
Yes, ma'am.
Energy and results are very correlated. So from this session, if you want to get maximum out of it, you want to understand it, so that tomorrow if you have to speak to someone that I attended a course on Mars, you should be able to speak 10 sentences without having any pen and paper or anything with you. Yeah. So for that thing to happen, I want the crowd's energy, that is your energy, to flow towards here. Okay. So that the more energy it is, the more you will be getting back from here. Okay. So why what we want to study in Mars? When we see Earth, what is Earth having? It is having atmosphere, it is having terrain or topography. Okay, we have rivers, mountains, lakes, yeah, plateau. Similar topography will Mars will be having. Okay, so topography, atmosphere. Third thing, just think over it.
Natural
Living-
resources.
living organisms.
Living organisms. Okay, presence of water. Okay, these are the small
Oxygen.
things. That oxygen, presence of oxygen. Okay, the fourth thing is, what are the minerals present on Mars? Yeah. Okay, how many of you know about Chandrayaan 1? You would have heard it, yes?
Yes, ma'am.
Okay.
Yes, ma'am.
So what did Chandrayaan 1 do? Chandrayaan 1 found water on Moon. Yeah.
Yes, ma'am.
What did Chandrayaan 2 do? It mapped the mineral, it gave the mineral map of Moon. Okay. So this is how, with these information, maybe the third thing we want to know is that what is the topography, exact topography of Moon. Yeah, what is atmosphere, more onto it. So similar for the Mars, we are taking a step towards it. Okay. Now, the journey to the Mars didn't started with Mars orbiter mission. Before that also, there have been many missions to Mars. Okay. When we say many missions in terms of the space exploration, it means if there have been like 4 or 5 missions, it's many. Yeah. Yes, no?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
रोज तो नहीं भेजते हैं. Okay, so there have been a few missions. So the first one was in 1965, which took up. और ये missions करते क्या है? Like, what does this missions do? Okay, so I have a phone. All of you have. Yeah.
Yes, ma'am.
Yes, ma'am.
I take a photo and send to someone. What will the other person do? From seeing that photo, he'll be trying to analyze that photo. That what is there in that, who all people are there, where are they? Like, how is the background? Did the picture come good or bad? Yeah. So the same thing we do for the Mars. We take its picture, or what we call it as the data, in a different electromagnetic spectrum range, and then try to study it. Okay. For example, when we take a photo from phone, we see the optical data. RGB image milti hai na? We get RGB image.
Yes, ma'am.
Yes, ma'am.
Yes.
ma'am.
Okay.
Yes.
Similar to it, if I'm taking a photo of Mars from a payload or a satellite or an instrument, it is nothing but an instrument, a collection of instrument. Depending on what the instrument wants to sense, I will be getting different kind of information. Not only in RGB, but also in other radiations. For example, ultraviolet, that how it is, how is the image in ultraviolet, in infrared, okay, in X-ray, depending on what kind of sensor we are sending. You would be knowing that, how this uranium, how do we come to know whether there is uranium or not? Uranium actually gives fluorescent light in ultraviolet radiation. Yeah. So what happens is, when you want to scan a uranium, that this rock is having uranium or not, we have a instrument that is having UV rays in it. Okay, we keep the uranium wala block down there and we see with it. So if it is showing a fluorescence, we come to know that yes, this block is having uranium. Yes.
Yes,
Yes,
ma'am.
ma'am.
Yeah, okay. So, similar to it, using only RGB, sometimes it is not a very good idea to get all the information about things. Yes. So for that, we use a very large, what we call it as the bands of electromagnetic spectrum to read the data. Okay. Now, why Mars is important is something that we have discussed. Okay. I don't think that we can, we should, invest time on it, but we should like take it to more. Anyone wants me to go through it again? You already have answered most of it.
Ma'am, can you please explain the second point? The study of Mars can help us to understand the history and evolution of solar system.
Okay, yes, of course. See, to study this evolution of solar system, there are multiple parameters, and Mars is one of them. Okay. For example, if there was a life on Mars before, how did it end? What were the reasons? You would be knowing one simple example I would give. Space is dynamic. ये term किसी ने सुनी? Have you heard this term? Space is dynamic.
Yes, ma'am.
Yeah.
Continuously evolve.
The
Yes, yeah.
Yeah, it is continuously expanding, it is continuously shrinking, we don't know. है ना? We can just make some studies to tell. Or maybe it is just expanding, reducing, we don't know. Yeah? So, similar, like what is the distance between Sun and Earth today? It might not be same as tomorrow. Or maybe it might not be same as what was some 10,000 years before. Yeah? So,
Yes.
how, how all these parameters have changed in Mars can help us to study that how this evolution would have taken place and how and what is the rhythm with which we are moving at this point of time. Yeah, at this point of time we are rotating also, we are evolving also. If we imagine, we will get vertigo. Yes, but we don't get that feeling every time, no?
Yes, ma'am.
Yes, ma'am.
Yeah, similar to it, to study the evolution, Mars is one of the things that with which we can get to know. Did you get my point? That is one factor.
Yes, ma'am.
What are the rocks? How they have changed? Okay. Uh, yeah. So how the Martian environment would have changed? It would have been possible that maybe a few lakh years before Mars was Earth and Earth was Venus. Now Earth is Earth and Mars is Mars. Possible?
If
Yes, ma'am.
Imaginable? Yeah.
Yes, ma'am. Everything about
Huh.
universe is a theory and which was imagined by some or other the scientists
Huh.
according to their assumptions.
Yes, yes. So, especially in this field of space science, usually we work on assumptions and then try to see whether our assumptions are correct or not. Because, see, what happens is, if even in our personal relations or psychologically saying, 90% of things work on assumption. Okay, for example, I'm assuming as of now that you are listening to me. It could be possible someone would have, just kept the phone and went off. Yes.
Yes.
Yes, ma'am.
But if I don't assume and don't speak, then, there will be no progress. So for progress to happen, I have to assume that all of you are listening to me. The similar case goes with the space. Yeah.
Yes, ma'am.
Okay.
Yes, ma'am.
So now why Mars is important? We are seeing for the future to colonize there. We are going to understand what is the geology, what are the potential resources. For example, Mars, if we get a lot of uranium and we are able to bring it back to the Earth and we are able to, have a good nuclear power stations in India. And if we have the technology to bring uranium from Mars, then India could be one of the richest nation in the world. Yeah. So to study all these things, it is important to study the Mars. Got my point?
Yes, ma'am.
Yes, ma'am.
So going further onto it, like what is Mars actually composed of? So here a photograph is given, a rough estimate of what Mars is having. So it is maximum having carbon dioxide. Yeah.
Yes, ma'am.
Then nitrogen and argon, and these are the basic things, and that is why This is the main reason that Mars look a little bit of oxidized or rusted or having a rust color. Okay, so this is about what is the composition of Mars. Going on to it, going on to the atmosphere. How do you think would be the atmosphere of Mars? Acha, okay, let us not go to Mars. Let us first reach Moon. Yes? How do you think is the atmosphere of Moon? Have you seen some pictures of some people who have been to Moon?
Yes, ma'am.
Yes, sir.
Neil Armstrong,
Ma'am.
राकेश शर्मा. या कैसा लगता है एटमॉस्फेयर
The atmosphere.
of Moon?
Yes.
It
Very
is
cold.
having a
Yes,
very
sir.
okay. It is
Cold.
having a very cold atmosphere. It is having a lot of dust. Okay, it is having a very thinner atmosphere and it is having a lot of dust. Okay, so man have been to Moon, so we could study that. Now let us see towards Mars. So Mars atmosphere is majorly comprising of this carbon dioxide, nitrogen, and argon, and the surface pressure at Mars is only 1%. Okay, I will just give you something to think on. Um, uh, where is our heart? Everyone knows where is our heart.
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. So our head is at a lesser distance to our heart, and our legs or our feet are at more distance to our heart. Yes?
Yes, ma'am.
Yes, sir.
Yeah? Okay.
Yes.
So, and the heart is sending the blood to our feet also and the blood to our brain also. Yes?
Yes, ma'am.
Yes, ma'am.
Okay. So, and Earth is having its gravity. Because the gravity is more, that could be a reason our heart is at above place. Because to send to brain, it has to reverse the gravity. Yes?
Yes, sir.
Okay. What do you think would be the case if man was there on Mars? Just search about it. Maybe it is not a question, but this is something because I'm at ISRO. We keep on just imagining things or discussing ki agar if the man is on Mars, what would be the place of heart? Okay, just see the gravity and just try to think over it maybe after the class. Okay, so then you will get the idea of why we need to study the surface pressure and other factors before even imagining a colonization in Mars. Yeah.
Yes, ma'am.
Okay. You would be knowing about this Gaganyaan mission, human space flight mission of ISRO.
Yes, ma'am.
Yeah.
Ma'am.
Okay. You would have at least known the name. So in that also, when we are sending the man onto the space, we are actually creating a crew module. So the crew module will be having the Earth-like conditions. Okay. So that the humans can survive there. All these international space stations, they are actually they have what we call as a gravity is induced in that artificially. So all these space stations are even this our Gaganyaan mission is planning to send a crew module in which this artificial gravity will be sent to create a Earth-like condition so that the humans can survive. Similarly, if we are planning to send man on Mars, we need to know about the surface, we need to know about its properties, and we also need to know about what will be the how it is possible for a man to go there. Okay. So let us look at a little bit more about this Martian atmosphere. So Martian atmosphere is actually having two layers. Okay. So when we call it as the lower layer and the upper layer. The lower layer is thicker and it is like, of course, it's lower, so it is near the surface. And same like Earth, as we go to at the higher altitude, the layer becomes thinner. Okay. So why do you think the layer is the atmosphere towards the surface is very thick?
Ma'am, due to gravity.
Due to gravity. Very good. Okay, so similar to Earth, the Mars is also having a good gravity, and that is why it is having a thicker atmosphere, which is majorly having a lot of dust. Okay, so it is having carbon dioxide. Carbon dioxide is a greenhouse gas.
Yes, ma'am.
Yes, yes, ma'am.
It traps heat.
Yes, ma'am.
Yes.
So Mars is hot. What is the reason?
The amount of
More
carbon dioxide.
Yeah, okay. So you are able to link the things now. So this is how, like, when we study the Mars, we actually get to link the things and then plan further. Okay, this is what this is how it answers about the that why Mars is red, or maybe why Mars is hot. Yeah, because of its composition. This is how scientifically we answer a lot of things which seem to be very normal. No, as normal as like apple falls from the tree. Did you get the point?
Yes, ma'am.
Yes, ma'am.
Okay, so a lot of dust storms are there. Martian atmosphere is having a weak magnetic field than Earth, and so it is not as protected from the solar winds as the Earth is. Because in case of Earth, what happens is the solar wind, whatever it comes now, Earth just repels it because of its strong magnetic field. Okay. But that is not the case in the Martian atmosphere, and it is also having a very thin layer of ozone which protects it from the ultraviolet radiation, and this is also one of the reasons why we can think of a establishment in Mars. Okay, so far things are clear to all of you.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
So if I ask any one of you to brief me about Mars, say I want each one of you to say one sentence about Mars, and I just want to see 4 unique sentences. Okay. Yeah, can you start, any one of you?
The Martian atmosphere is divided into 2 layers.
Okay. Another one. Mars is majorly having
Carbon dioxide.
carbon
Carbon
dioxide.
dioxide.
Very hot.
Okay, yes, very good. Why we should study Mars?
Mars is a planet where we can rehabilitate after Earth is gone.
Okay, I hope Earth does not go, but now you are in a condition to speak up, yes, confidently. Yeah. Any other point? The 4th point.
We can understand the existence of the universe. How did it evolve?
Existence of the universe. Very good. Okay. So now let us look at a few missions to Mars. The first was the Viking mission, which went into 1970s when most of us were not even born. Yeah. And it successfully landed on Mars. Then in 1996, we had this Surveyor mission. So in all these missions, can you see that some satellite type of thing is there?
Yes.
Okay. So this satellite or payload is it's majorly having the sensors that sense the data. Okay, maybe we'll be like further going on to it. Then we had other missions, like we had Phoenix, we have Curiosity rover. Then we have our India's Mars orbiter mission that went in 2013. Then after it, trace for observing the planet, we had another Expo Mars trace gas orbiter to study specific the atmosphere. Then we had Inside rover. So many rovers have been sent. Yes. In astronomy, when we look at the astronomy or these interplanetary missions, there are 3-4 levels of it. Okay. The first is sending something to the space, and developing that thing is one component of it. Okay. Another component is whatever data we will be getting from there to analyze it. And that is what is called as an observational astronomy. Okay, so suppose if tomorrow someone asks you that you did this Mars course, what did you do? What you did was called as observational astronomy, that you are observing the data or you are analyzing the data, whatever you are getting from the Mars, from different kind of missions that have been sent so far. Is it clear to all of you?
Yes, ma'am.
Okay.
Yes, ma'am.
So, so far you're able to get the class now.
Yes, ma'am.
Okay. So now let us see. Now we have looked a little bit upon the Mars. We have looked a little bit upon the what are the missions. Okay, that is a little theoretical part. Now let us look at
Ma'am,
huh?
ma'am, I want to ask that why the manned missions are important. If we can get all the data through the rovers and satellites, why sending mans are important to Mars?
Okay. See what happens is if I being at ISRO, if I give this answer, uh, the thing is there are a lot of things that the data cannot do. The data cannot explore the possibility of life there. With data, we can just assume the things, but to have a confidence on it or to prove that thing, we have to experiment on ourselves. Okay. For example, what are the complications we cannot get onto it without sending a man on moon? Okay, for example, if I want to establish a colony in Mars, then I have to send a person on Mars. Before I don't send a person, whatever I would be doing is just an assumption. And it's not that we are eagerly looking to send people on Mars. Before that, humanoids will be sent. This art, robots.
Yes, ma'am.
Even this Gaganyaan, we are first sending this Vyom Mitra.
Yes,
That is
ma'am.
a AI ka robot,
A rover.
humanoid.
Yes.
Yeah, human robot, human. So this is how the process is. So that is why sending someone on moon is from someone on
To gain
directly
a
to that to study is important
physical experience.
to gain a
Okay.
physical experience.
Okay.
है ना? So the thing is, you might have heard na mare bina swarg nahi milta. So someone has to do there to see the possibility of it.
Yes.
Okay,
Okay.
for example, agar international, if there was no person sent to this international space station, we wouldn't know that humans can also survive in space.
Yes.
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 Now we have confidence over it because we have already done that. We, by we, I mean humanity. Okay. So now let us look at how machine learning is helping in Mars mission. That how to further experience Mars or to further explore Mars, how it is helping. The first thing is autonomous navigation. You would be knowing that Chandrayaan 2 also aimed at sending a rover on Moon.
Yes.
Yes. Yes, ma'am.
Yes, similar to it, when we are sending a rover, we first need to know that where the rover will be landing, where it will be going. We have to, using this AI, ML, and deep learning, we have to train the rover. The atmosphere of Mars, the atmosphere of Moon is not as comfortable as Earth. Yes?
Yes, ma'am.
If it is a plane, it's a plane. If it is a mountain, it's okay, mountain. Understood. But there are the atmosphere or the terrain is having a lot of craters. So in that case, we need to train the rover that if you see a crater, you are not supposed to land. If you see a hard surface, you are not supposed to land. For example, here on Earth, we are having, suppose if I have two places. One is a iron, okay, एक block है which is full of iron, an iron block. Another thing is what I'm having is a mud, the normal ground that we are having. If someone falls on iron from a great depth, what will happen? Gone. Yes.
Yes, ma'am.
Yes.
If someone falls on the ground, possibility is there that only like little something will be there, it will be survived. So this is how when we are sending a rover onto a different planet, we also need to have an information about what is the mineral, what is the composition, how is the topography. All these things have to be taken in the picture to train the rover that here you are supposed to land, here you are not supposed to land. Did you get the picture clear? Then how do we do it?
Yes, ma'am.
Okay. Another thing is using image processing, using the satellite data, we can get an idea about the Martian surface, and we can also detect that are there any signs of present life or possible life, or what kind of things are there. Then can also help in decision making. Rover, I gave the example that rover has to decide, and also to create predictive model. For example, if a river is going from here till there, so we see that, over a period of time, the width of the river increases, expands. Yes. So we can make a prediction that after this phase, this much will be the width. Yes.
Yes, ma'am.
Yes, ma'am.
Yeah, similar to it, in the planet's geology or the internal structure, we can have a predictive model. Internal structure, what will be inside the planet ka topography, geology, we can also have a predictive modeling. So these are some of the AI application that we can do with the data from Mars. So this is one of the case study, like NASA's Mars 2020 mission, and a case study is presented here, in which this Perseverance ka naam to, I hope, like, if you are like a little bit of astronomy, if you have an interest, you would be knowing about this Perseverance rover, which landed in on Mars in 2021, and it actually gave the data for autonomous. It used these technologies: autonomous navigation, image processing. Sorry, taking the samples containing the like seeing that if there was some past microbial life, and also then predict and analyze that what are the chemicals, what is the mineral composition in Mars. Talking about this Mars orbiter mission, uh, any one of you know about this Mars orbiter mission? What are the, what are the things that we got from it? Okay. So all of us are just aware कि ठीक है मार्स पे गया, and aware कि ठीक है अभी इंस्ट्रूमेंट काम करना बंद कर दिया. But at this level you need to understand that what we have sent to Mars, as I was speaking before also, that we deal with a different kind of cameras that can sense different type of electromagnetic spectrum. So we have sent the colored camera, then methane to detect the methane, then to this another analyzer that studies the upper atmosphere. Then we had a photometer, and then we have the thermal imaging camera, spectrometer. Okay. And what we got from as an outcome from Mangalyaan is we captured a lot of images of Mars in a very high resolution data. And not only resolution in terms of the pixels, but resolution in terms of the number of bands it has captured. And the instrument that we had sent was able to detect methane. Then using this, we can actually, get the mineral map of the Martian surface. And this is what is the success of this Mangalyaan mission. So now what is the state of art as of now Mangalyaan mission is concerned? We have now got the images. Now it is the duty of the analyzer or the observational astronomers to study this data, and at a lot of places, for example, physical research laboratories there, and other places also I know, where they are actually working on this Mars data and trying to make the mineral map, or what is to trying to analyze the mineralogy of Martian surface. Okay. So this is again like just information that ISRO is planning to send another mission to Mars. Now let us go on to what is rover, what is autonomous rover. Okay, so rover is just an instrument. You might already be familiar with this remote control cars. Yes?
Yes, ma'am.
Yes, ma'am.
Rover is nothing but just a autonomous car. It has to decide on its own where to stop, how to go, what to do. And that's how we do it using how do we automate it is by training it with the samples we are having. Now, in this case, we actually deal with machine vision. Okay, what is machine vision? I'll just simply give you an example. If I see a ball is coming towards me, what will I do?
You will move far away from
I
it.
will move far away. Okay, I'll change my direction. Yes. So what is the thing that I did first? I visualized that a ball is coming near me. Then I use my intelligence, okay, to see what reaction I should give. Yes. Similar is machine vision. If this kind of activity I'm expecting from a machine, That is called as a machine vision, that it will see the thing, it will analyze on its own based on its prior learning. I know it has been taught to me ki bhai ball, if the ball hits me, I'll get hurt, so I should move. Yes, this kind of ability we have to give the machine, and that is what is called as the machine vision. Okay, so the components what machine vision is having apart from that machine is that it is having a vision, that is a camera that is automatically detecting something, and based on it, it is giving the output. Yes, or the next set of action. Okay, you might all have been to airport or malls. We do this purse ka scanning now, purse bag yeah.
Yes, yeah.
At some places, if there is something found which is like suspicious, the machines beeps na, beep 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 beep. Yes.
Yes, ma'am.
Okay, that is also machine vision. That the machine is seeing the data. If it is finding something suspicious, it is responding. Okay, so and it is being used in a lot of application. For example, object recognition, pattern recognition, OCR. Okay, one another example of machine vision is which is like very recent technology. How many of you have seen this police vans standing somewhere, mobile police, like mobile vans standing? Like if I speak about Trivandrum, that what is the name of near after Perurkada we have uh, even at Perurkada this mobile van stands now that automatically captures that at what speed the car is going. If the car is
Yes, yes, ma'am. Yeah,
if the car is
Yes,
crossing
yes.
that speed, automatically the challan will be sent to you.
yeah.
Okay, so this is what the machine vision does. So this is a like a general machine vision wala jo hamara autonomous rover hota hai. This is a general structure of it, like basic things it will be having. It will be having first the illumination, like what surface it want to see, it will like first throw the light on it. Then camera, of course. Then whatever data it is capturing from this camera, it has to be imagely, like we do image processing on it using the software, and based on the image processing, whatever the result is there, the belt or the conveyor belt or the direction of the rover would be going in that direction. Okay, so these are just the components of it. So when I talk about this lighting, so any of the machine vision could be a active or a passive. What is active? In which we are sending the light. For example, it's a night. If I want to take an image, I will turn on my flash. Yes,
Yes, ma'am.
that is called as active lightning. If it is a daytime, I need not do it, and that is called as the passive lightning. Okay, so after lightning, we have a different type of camera. I told you that in our in our normal phone we take the RGB image, but in when we want to study Mars, we will take it in a broad range of electromagnetic spectrum, starting almost from this. Gamma rays going up to the radio waves and seeing the structure. Okay, so see what happens is why do we take different wavelengths? Any idea?
Different living organisms comes under different spectrum of rays. Here us.
Yes. Okay. Yes. Because different objects respond in a different manner. For example, with a visible light, I cannot see my ribs, but with X-ray, I can. Okay, so that is why I take it in a different electromagnetic radiation. Then we have a optical system, and in optical system we actually fix the camera. We also fix the size, and draw, pitch, yaw are the errors, like in the inclination if it happens, so that we get the exact picture. Okay, see in Mars, or when we are sending anything to other planet, in Earth we are having latitude and longitude. Yes.
Yes, ma'am.
Yes, ma'am.
What is latitude and longitude? Imaginary lines. Yes.
Yes, ma'am.
Okay, so if I'm making a satellite revolve around Earth, it will be taking a lot of pictures. Yes.
Yes, ma'am.
There's and one more task, that we have to combine all the pictures to bring the picture of Earth.
Yes, ma'am.
To combine the picture, we need this some GPS or some latitude, longitude, or some information. Okay, it could be possible some pictures would have been taken straight, some pictures would have been, in some pictures camera would have been tilted and other things. Yes, and we need to correct and then join them. Yeah.
Yes, ma'am.
Okay, so this is for this. This is also done in Mars. In case of Mars, we don't just take the pictures; we combine together to make the big picture. If you would have seen this Mars, this Mangalyaan ka movie, one patch is coming at a time, na?
Yes, ma'am.
Yeah.
Yes,
So that
ma'am.
is also one of the thing we called it as ortho rectification that we do uh, on these data, and that is why this camera tilt and other things also become a very important part of it. Okay. Now, another thing that we are having are different type of sensors. So here we usually use this uh, based upon what electromagnetic spectrum we want to study. We take different type of sensors, which are usually in a CCD style. What is a CCD style? It's nothing. It's just like a checkboard. Whatever signal will be going, hitting, accordingly it will create the data. Like, suppose if I'm hitting something in the play, in some this in malls, this play area section, you would have looked na ki you hit the ball, they will tell you with what intensity you have hit the ball.
Yes, ma'am.
है ना?
Yes, ma'am.
Okay. Similarly, how these sensors work is the data. From example, light. Say we have this sunlight. Yes, sunlight is from. If I'm speaking normally about RGB, we have a wavelength, which is of say 700. Apna 700 nanometer.
400, 400 to 700.
Okay, 400 का हमारा wavelength है. It is hitting the surface of Mars and it is reflecting, and that reflection is captured by the sensor, like one of the cell of the sensor. It will say, okay, this is the intensity what I have got. So it will produce one data, and that data is combined together then to form the big picture. Okay, got the point?
I had a question.
Yes.
How often do you receive data from a rover?
See, it depends. What happens is there are two things. It depends on what is the application. If you're asking from a normal satellite, if the application is a defense application and it is very urgently needed, within 20 minutes the data will come from space.
Oh, okay.
Okay, but if the application is not that much needed, what is always preferred is in a satellite or an instrument there is internal computing. They don't send all the data, they just try to filter out the data and then send it. So it completely depends on what are the specifications that we have set.
Right.
Okay, so then vision processing, I have already explained it to you, that we see and then accordingly we act. Okay, so when we talk about this computer vision or machine vision, what are the steps is we take an image, we process the image. For example, what do I mean by processing image? I have taken a photo and I want to okay, how many of you use this face cam hota hai na hamara? Like when we use a phone, it opens with our face.
Yes, yes, ma'am.
Yes.
Takes
Okay. So it has, what it does, it acquires a digital image, it pre-processes the image, converts the image to RGB, see where our eyes, nose, lips, these are the things it detects. It sees that unka what is the like, it calculates some features. For example, the distance between eyes, the distance, like, what is my what do you say, like width upon length ka ratio. These are like some features that it can calculate on its own. Okay, and based on these features, it then further analyzes the image and do the action whatever is needed. Okay, then we have another thing is like, how do we send information? So this is another part that you wouldn't be dealing with in this case. In this case, what we will be dealing is with like, how we are using this Mars ka data for our understanding. Okay. So when we go to computer vision, there is one thing that comes as image segmentation. Okay, so this is one thing, is when you have an image, you can do multiple things on it. Yes. Yes,
ma'am.
no.
Yes, ma'am.
Okay, one thing is image recognition, that how much
Sure.
portion of the area is covered by sheep, how much is covered by dog. That is one simple thing you can do. Another thing is extracting the sheeps, extracting the dog. Another thing is, okay, this is sheep one. Another thing is sheep, 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 and dog. Okay, detecting sheeps. Another thing is like this is object one, object two, object three, object four. That is called as the instance segmentation. So depending upon what application you are having, you would be doing different kind of actions. Okay, if I relate this thing to Mars, what do you think if I want to study just the surface of Mars and see this is my rover, and the next place, the next spot that it has to take is a crater or a hole. So what would be like, my thing, what would I be doing? Segmentation, recognition, detection, instant segmentation. Suppose the surface is having a lot of holes, and we want to take our rover we have to create a path for our rover, which so that our rover does not fall into hole. Simple, imaginable.
Ma'am, recognition.
Recognition, no. Like recognition will just tell that how much portion is.
Segmentation.
Instant segmentation, like it will give us idea कि like rover गिरेगा कि नहीं. This whole-
इंस्टेंट सेगमेंटेशन में क्या होगा? होल 1, होल 2, होल 3, होल 4. Do we need that?
Semantic
Semantic segmentation. Hole, non-hole. Yes. Then I can take my this rover through non-hole region. Got the point?
Yes, ma'am.
Okay.
Yes, ma'am.
So basically, it filters whatever we needed. Is
Huh.
it like that?
Yeah. Okay. So then we have this machine vision and computer vision. There's a small difference. In machine vision, the machine automatically understands, it takes the photo, and everything is real time. In computer vision, we already have the photo and we are just trying to understand it. Okay. What is the difference is if this image is given and I'm applying some algorithm on it. This is computer vision. Okay, if I'm trying to understand that what is the traffic light, this is computer vision. But if this image is given and the machine is automatically understanding that the traffic light was red and this car number has crossed the traffic light when it was red and automatically send the challan, this is machine vision. Did you get the difference between machine vision and computer vision?
Yes, ma'am.
Okay, great. So how do we do this computer vision or machine vision? Is we use different programming language. Okay, so we have a lot of programming languages. We have Java, we have Python, we have C++. Then any other MATLAB is there. Okay, so we basically for this machine learning, deep learning, as of now, Python is the topmost application, or what we can say is a programming language that is being used because it has a lot of, it is very versatile. Versatile means at a lot of applications it can be used. Okay, so it is having a lot of libraries like OpenCV, TensorFlow, CUDA, using which we can do this image processing things. Okay, now how this course will help you is it will get you through a basic understanding of machine learning, that how machine learning mathematically, statistically, logically work. Okay, it will relate you with the programming thing, that IT thing that we do, that how to load a image, how to analyze the image, what do we say it is, how to create different type of matrices which are required, how can we do machine learning, what are the results that we should look forward when we take an output of machine learning, and it will also give you information about this data science domain. Okay, so this project, okay, so all of you reached college after doing first, second, third, fourth up to 12th. Yes.
Yes, ma'am.
If I say you study A for apple, B for ball, C for cat, it would look very silly to you. Yes, but do you
Yes.
all agree that that contributed to building what you are today?
Yes, ma'am.
Yes, ma'am.
Yes. Similar thing goes on when you do these kind of courses or these kind of project based learning, that we start from scratch. So at first it might look that what am I doing, I'm just learning how to load an image, but that actually builds the podium for you to develop a a sophisticated algorithm over it. Okay, so you will be starting with another lecture would be there on this problem formulation, then the basic of Pythons, what are the Python libraries, how to make you comfortable using Python, then do image processing on Python, then coming to machine learning, first the theory and then implementing it, and then telling you that how you can optimize or how you can improve upon your machine learning algorithm, how you can improve the accuracy of machine learning algorithm, then what are the use cases you can take from that thing, and then tell you more on the research, that how you can do your research onto it, and then finally coming on to the structure, like how you can structure the whole course that you have studied for your further benefit. Okay, so this information I hope most of you would be knowing, that this is a 6-week course. Yes, and the classes will be on Monday, Wednesday, Friday from 7 to 9 p.m. And any doubt you're having, you can connect with the Rohan. I hope like you will be having access to the Slack platform.
Yes, ma'am. I'm the one who's going to solve all the doubts. Sir.
Okay. So yeah, this is the general thing about this course. Hope you get a lot of learning, and hope you all are able to utilize it in upgrading your skills and having a new skill set in your hand. So all the best to all of you.